In the vast expanse of the universe, there are many mysteries that continue to baffle scientists. Three of these enigmas are baryonic asymmetry, dark matter, and dark energy. Let's delve into each of these fascinating topics. Baryonic asymmetry refers to the unequal distribution of matter and antimatter in the universe. According to scientific theory, the Big Bang produced an equal amount of matter and antimatter in the universe upon its birth. However, in our universe, baryonic matter dominates antimatter, which is almost absent and sparse. Why is this the case? While it is challenging to quantify the exact amount of antimatter present and if it is hiding somewhere in the universe or not, scientists hypothesize that larger amounts might exist in cosmic phenomena like active galactic nuclei or black holes. However, these speculations require further investigation and verification. Antimatter, as its name suggests, is the counterpart to normal matter. It is composed of antiparticles, which possess opposite properties to their corresponding particles. For example, an antiproton is the antimatter counterpart of a proton, and an antielectron, often called a positron, is the counterpart of an electron. The ordinary type of matter that makes up everything we see around us is called baryonic matter, from the stars and planets to the air we breathe. This substance is made up of elementary particles like protons, neutrons, and electrons. These particles join together to form atoms, which in turn bind to create larger structures like planets, stars, and galaxies. However, baryonic matter only accounts for a small fraction of the total composition of the universe, around 4.6%. Enter the intriguing realm of dark matter, an invisible substance that permeates throughout space. Its existence is inferred by its gravitational effects on visible baryonic matter. Despite its elusive nature, it is believed to make up a significant portion of the universe, around 24%, surpassing the total amount of baryonic matter and antimatter. The effects of dark matter can be observed indirectly through its gravitational pull. Galaxies rotate faster than expected based on the visible matter they contain, suggesting the presence of additional mass. It is believed that dark matter provides this additional gravitational force, holding galaxies together and preventing them from flying apart. The universe's composition becomes even more captivating with the inclusion of dark energy. Back in the 1920s, astronomer Edwin Hubble made a groundbreaking discovery through the observation of distant galaxies. The universe is not static, but rather, it is expanding. The light from distant galaxies appears to shift towards the longer wavelengths of the visible light spectrum as they are moving in a direction away from the observer. This phenomenon is called redshift. Its opposite effect is also known as blue shift. Dark energy is believed to make up about 71.4% of the energy content of the universe. This enigmatic force is responsible for the expansion of the universe, acting against gravity. Dark energy, like dark matter, cannot be directly detected or observed. Its existence is inferred from the accelerated expansion of the universe, making it an integral piece of the cosmic puzzle. Together, these four components, antimatter, baryonic matter, dark matter, and dark energy, form the intricate composition of the universe. While baryonic matter dominates on smaller scales, dark matter plays a crucial role in shaping the large-scale structures of the cosmos. Dark energy, unlike dark matter, is more of an invisible force that fills the entire cosmos, pushing galaxies away from each other at an increasing rate. As we continue to explore the wonders of the universe, the quest to understand the complete composition remains ever fascinating. Each discovery, each exploration, brings us closer to unraveling the secrets that lie within this awe-inspiring cosmic tapestry. And with each step forward, the universe reveals more of its captivating composition, tantalizing us with its awe-inspiring complexity.